Hey, welcome to another training video. My name is Chris, and today we're going to be focusing once again in Conversational CAM Pro. We're going to be looking at a toolpath known as the spiral rope twist. And so in the previous one, we looked at the spiral barley twist. This one's going to be a slightly different type of twist, the rope twist. And we're going to answer two questions, just like the others, of what does this toolpath actually do? Okay, what does the material result look like when the cutter is done with it? And two, how do we program it? How do we control it? And so we're going to answer those two questions using visual aids with our Vectric CAD software in a 2D CAD drawing, as well as the cutting results actually on the CNC machine so you can see what the cutter is actually doing to the material. So let's jump on over to our Aspire software, where we've already had this design laid out for a couple spindles already. So we have a square section on this end, square section on this end, and the center section is all going to be turned around. Okay, so the middle section that's been turned on has already been programmed with a turning around process using our surfacing cutter, starting here, turning all the way down and ending here. And the classic spiral cutter has done a two tool profile cuts here and here. If you haven't seen those videos, please do so. Those are key turning elements that you're going to be applying to your turning capabilities here in the Legacy CNC all the time. Okay, but today again we're focusing on the rope twist effect, and we're going to be using a specific cutter for this. This is called a rope molding or rope twist cutter, and you can get this from again magnate.net. Okay, now what this cutter is going to do throughout this toolpath is it's going to come to the start position, which I'm going to make here the same position as this tool profile. So I'll just hover directly over that surface. And the tip of the cutter will actually start at the section diameter and then plunge down to the depth of the tool and then cut down the stock. So this is just going to travel down the stock. As the stock is rotating at a controlled speed, giving us a twist effect, we'll end it here at this position, and then it will lift up out of the material. And that will just repeat multiple times for multiple starts. So unlike the barley twist video that showed a barley twist cutter doing a single start spiral, just back to back to back, this one is going to be doing a multi-start spiral twist. That's because a strand of rope has multiple strands, traditionally 3 strands of rope. And so we're going to be matching that type of look using a 3-start spiral twist. So now that we have at least a general understanding of what the cutter is going to be doing throughout the toolpath to the part, let's give you some additional visual aids. Right here, this isn't required for programming, but it does help. It does help visualize what this is going to look like at the end of the cut. Okay, so that cutter again is going to start here, travel down the stock while rotating, and then lifting up, giving us this result. Right? And you can see from a cross-section view that the cutter is going to have multiple starts evenly spaced around the circumference, and all 3 of those will be twisting around each other down the length of the material, evenly spaced. Okay? And we'll talk about that specifically in just a moment when we get into the actual programming. So with a good understanding, again, of how this functions, let's go back into CCAM Pro, and we're going to go to our project that we've already created, and we're going to go to our part, the training spindles, and select that part and manage our toolpaths here under the turning round sample. So we'll go here to manage toolpaths. And so we need to add and focus specifically on a spiral technique, the rope twist process. So if we add that, that's now in the order sequence we need it to be, and we can close that. And we have a rope twist that we can now finish programming. So we'll click into this, and we have our questionnaire that we're going to be filling out. So the first thing we're going to do is select a tool. So if we click on this field, we can go back to our tool database, and this is called a rope twist cutter, and we have lots of different sizes. Now the one I had on my drawing board at this time is a 1.5" cutter. You can really use any cutter you want. It will give you slightly different results in the look of the twist based on the size of the cutter relative to the stock diameter. And so I want to see if I can give you a good, way to find which one would work best based on what you are turning at that time. Okay, so if we select this tool, let's go back to our drawing board. I'll make this tool 3. Because the surfacing cutter is tool 1, the classic spiral is tool 2, and so this is tool 3 in this entire spindle. And so let's go understand why I chose 1.5 inches in our design in the first place. So going back to our drawing here, okay, because we're going to be having 3 starts in our spiral twist, you can actually see that in CCAM Pro. The number of starts right here defaults at 3. Okay, so we're going to go off of the default of 3 starts to know what that means relative to the cutter diameter. So what the software does is it takes the cutter diameter and the number of starts, and that gives us what's called a pitch. How far the cutter travels down the stock per rotation, right? So if this cutter was here, and then how far would it travel down the material per rotation? Well, if you actually look at this, I mean, we can't see the backside of the spindle, but this would travel 45 degrees down to this section here. So the cutter would spiral around to the backside here and then back up to this position. So the cutter is actually traveling from this point to this point over that distance, okay? That's called your pitch. And the software automatically calculates the pitch for us in the barley twist, this rope twist process, and many others. All we have to do is choose the size of the cutter and how many starts we want to have. How do we choose the size of cutter that's going to be looking correct relative to the stock diameter? Well, here's the simple formula that we have used in the past for many, many years. This was back in our ornamental mill days where we figured out all these types of calculations. But a simple way is that you can take the stock diameter, and so if I throw a dimension out here so you can see it. So if we took the stock diameter here, which is 2.5 inches, and you multiply it by 2. So let's do this real quick. So if we took the stock diameter of 2.5 inches and we doubled it, okay, multiply it by 2. And what this number represents, this 5, would be the optimum pitch. The pitch is the distance the cutter travels per rotation. So if the cutter were to travel 5 inches down the stock per rotation on a 2.5 inch diameter section, it would give us this 45-degree angle look, which is really balanced. Okay, so if that's the pitch we desire, we just take the pitch and we divide it by the number of starts we want to have in our spiral twist. And again, this is how many starts are evenly divided around the circumference of the turning, wrapping around each other down the length of the stock. Okay, so we have our pitch divided in this case by 3 because we have 3 starts. And so this number represents our cutter diameter. It would be the optimum cutter diameter for this diameter of stock to hit that 5-inch pitch, right? But we don't have a cutter diameter of this size. That's a weird number, right? So we're just going to round up or down to the nearest whole number of the cutter diameter that we do have. In this case, 1.5 is the closest to this actual calculation that we have, which is exactly what we have here in our drawing. This is a 1.5 inch diameter tool, and that's what we chose in CCAM Pro, right? So if we go back to CCAM Pro here, the 1.5 inches is exactly what we need to get us close to that balanced look in our twist based on that stock diameter of 2.5 inches. So now we can fill out the rest of the parameters, such as where does the rope start and end, and what's our section diameter. So the rope start and end, that's our X positions. So let's go back to our drawing, and let's move this tool out of the way just so we can put our parameters up here. So if we go to our dimensioning tool and we go to our horizontal dimension, and we're going to click on the left edge of the blank because that's X0 in our turning center, right? So from X0, where do we want to start? Where do we want the center of the cutter to start? And I'm just going to have the center of this cutter start at the same position as this tool profile, okay? And that will be 5 inches. And if we go from X0 to the center of this profile, this will be the ending position, okay? So you have your start and ending position. And again, if the cutter were to start there, it won't cause any problems. Okay, so if the tool, again, is positioned here to where the shoulder is going to be at the depth of that 2.5 inches, you can see if it starts here, it's not going to be accidentally removing additional material because this has already been cut away by my larger profile cutter. Okay, so I can start there just fine. I mean, another place that I could start, this is always options, you can look at things, I could always start it right there. okay? So right where that profile, where it starts to go into the radius here, I could have the center of the cutter start there and measure from that point instead. It really doesn't matter. This is just really easy because I've already used these parameters in the program previously to do the tool profiles, right? So I used 5 and 13 to program those two profile cuts. So I could just use those parameters again for this rope twist effect, and it will give me a beautiful transition into the profiles, to the rope, back to the profiles, okay? So let's put 5 and 13 as our start and ending position. So going here, we'll do start position of 5, ending position of 13. And all of these, again, are defaulted. And we're just going to leave them as the defaults, and we'll show in other videos how to optimize these and change them in different ways to give you different results. But this is, for example, going to have 3 starts in our twist. It's going to be spiraling in a left direction. And all the feed speeds and pass steps is all taken care of for us. The only thing left over is what is the diameter section this is being turned onto for this rope twist effect. And so if we come here, again, that was the 2.5 inches. That's what was already turned around in the previous process, and we're placing that rope twist on that diameter section. So 2.5 inches is our section diameter, and we're done. We can now go finish and save. And again, we're not going to generate all the G-code together in this video because I've already cut the turning round and the tool profiles beforehand. So I'm just going to save out just the rope twist effect. Whereas traditionally, if I put just a raw blank in the machine, I would save all of these together in a separate G-code. But here we're going to be generating the G-code just for the rope twist, and that is going to perform everything we need for the rope twist effect, and we can go save G-code file. Okay, so under our toolpath demonstrations we've been doing, let's go to the spiral rope twist, and we're going to save this as a spiral rope twist G-code program. And we are now ready to go to the machine to see how this is going to cut. So just like we programmed, the cutter comes down directly over that turning tool profile, and it plunges down to the first roughing pass depth and travels down the stock while rotating the material. Once we get to the ending position, it's going to plunge to the final depth and come back in the opposite direction, giving us a finish pass. So this first start is complete, and here we can see it lifts up, rotates 120 degrees to reposition for start number 2, and this will repeat for all 3 starts. All the cutting advantages shown here are built in Conversational CAM Pro. We should now have a good understanding of how the spiral rope twist process works and what it looks like.
Now, these types of videos generate a lot of different questions. I recommend you take advantage of 2 resources to answer your questions. First is head on over to our website at legacywoodworking.com. There you'll find all the different product information, additional cutting demonstrations, and much more. The second resource I recommend doing is actually getting in contact with one of our CNC experts. You can call them at 801-491-0010. They will be happy to answer any of your questions, put on software or cutting demonstrations with the machines, and point you to additional resources, again, to fulfill your needs. Now, if you'd like to just simply watch more videos, I don't blame you. Just click right over there. I think we all know what to do. If you want to be notified of future videos, just click that button down below, and don't hesitate to give us a like if you liked what you saw. As always, thanks for watching, and remember, Legacy solves more woodworking problems and allows you to say yes to more opportunities than any other CNC manufacturer in the industry.